Hi students, in the previous video we filled out the left side of the second section of your trigonometry flipbook on the top flap. How does the altitude to the hypotenuse of a right triangle create similar triangles? So now what we're going to do is we're going to be able to use this knowledge to say, okay, if we know that an altitude in a right triangle creates three similar triangles, then we can find all kinds of missing angles and missing sides by using all of the things we've learned about trigonometry. So now we'll go to the right side of this video or this section, and let's take a look at this diagram. If CD is an altitude of triangle ABC, find the missing measurements. What we want to remember, and this is hard for a lot of us, we want to remember that this altitude right here, it creates three similar triangles. The big one, the large one actually, the medium one, and the small one, just like you see over here. So all we have to do is remember which angle is congruent to which angle in each of those triangles, and we can use trigonometry to find lots of missing information. And since we're going to use trigonometry to do this, let's write a couple of things that we've already learned to do, and that is we're going to write our something to remember our trig ratios. Whoops, it's not sun. How about so? Let's fix that. So, ka, toa. And let's remind ourselves that's telling us that sine, all abbreviated as SIN, is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse, and tangent, oops, do that in capitals. Try that again. Tangent is equal to opposite over adjacent. So now let's go ahead and use our diagram. Now you see we've been given two side lengths, and the question is, can we find all this information, these missing angle measures and these missing side lengths, by using trigonometry? And the answer is, of course we can, because we've got similar triangles here. So let's first of all start off with this one. Can we find the measure of angle A? I'll put a little dot right here, the measure of angle A. Let's put that in blue. So the measure of angle A. Well, sure, take a look at this. A is an angle of both the large triangle and the medium triangle, but on the large right triangle, we know, take a look at what we know. This is the hypotenuse, AB. This is opposite, and this is adjacent. So if we know opposite and adjacent, we can find the measure of angle A, and we're going to use inverse trigonometry. Let's put this little note here. We know opposite and adjacent. That's my and symbol. I can't write the whole words. Let's see if I can do that again. It's like a little upside down or sideways 3. Opposite and adjacent. That means we're going to use inverse tangent. Here we go. Inverse tangent. We know inverse tangent is opposite over adjacent is going to equal the measure of angle A. We look at the measure of angle A, that's what we want to learn, so that becomes part of our inverse trig equation, and we know adjacent right here, and we know opposite. Let's plug in the things that we know. So inverse tangent of opposite was 8, adjacent is 15, and let's put that in our calculator and we'll find the measure of angle A. So let's pull up that calculator. And I already typed this in. Let me do it again so you can see me do it. I'm going to use the Desmos calculator. I go to function, inverse tangent. I'm going to do 8 divided by 15 and close that parenthesis. Oops, not that parenthesis. Let's back up on that one. Let's close this parenthesis. And we end up with 28.0724. Let's round it to 2 decimals. So 28.072. So, oops. I just lost my whole file. Let's see if I can get that back again. Pretty sure I can. There we go. So this is equal to 28.072 degrees. And there's my angle measure. I'm going to try to write this in here real narrow. 28.072 degrees. There we go. All right. Take a look at the measure of angle B. Well, I can use any one of these triangles, but I got to know at least two of the sides to use inverse trig. And if you look at angle B, the only triangle I know two of the sides is back to my large triangle. So we're going to make a note here again. I know. Let's take a look at angle B. Well, angle B is part of the large triangle. AB is my hypotenuse. That means I know opposite and adjacent again. Same thing as before. It's not always going to be that way, but in this case, we're going to use the same side names. So here we go. I've got inverse tangent because I'm using opposite and adjacent. Let's take a look at angle B. Opposite is 15. Look what happened. It became the reciprocal. Adjacent is 8. And that's equal to the measure of angle B. So let's put that in our... Let's write this out and plug in what we know, and let's find the measure of angle B. Inverse tangent. Oops, you know what? I just realized I wanted to write this so you remember what inverse tangent is. Let's do that. It's opposite over adjacent. And now we're going to plug in what we know. Remember, angle B, opposite is now 15. Adjacent is 8. Let's put that in our calculator. I can bring that up. Clear this. Actually, you know what? Let's just go back. We already have inverse tangent here. Let's go ahead and put this in. 15 divided by 8. And now we've got 61.927. That's 61.928. Yep, let's do it to 3 decimals. 61.928. I'm just making it really accurate. I did it again. Okay. So 61, approximately 61.928 degrees. Let's see if I can squeeze that in there. Actually, you know, let's do an arrow. 61.928 degrees. In class, if you remember the Triangle Sum Theorem, you're going to know that if we did this accurately, if you add this angle measure A and this angle measure B and 90 degrees for C, they're going to add up to 180 degrees, which means we've got correct angle measure. So there we just use trigonometry. Now we just happen to use the large triangle for both, and that's just because, again, the only triangle that we know two sides of is the bigger triangle. If I want to find side length or angles, other angles now with the other triangles, I'm going to have to find more side length. Let's do that now. Let's go ahead and see what it looks like to find the length of side AD. All right. So AD, if I look at AD, AD is part of our medium triangle. Take a look at this. AD is part of our medium triangle. That means, let's label these. I didn't do this before. Let's label these. This is the hypotenuse of the large triangle. Here's the hypotenuse of the medium. Here's the hypotenuse of the small. And if we're looking at side AD, that means AC is the hypotenuse. Right there, hypotenuse. So I know the hypotenuse, and I want to know this side right here. And students, take a look at this. I've got an angle and a known side. I can use trigonometry. And I'm going to look at this using angle A. That means I want to know adjacent and I know hypotenuse. That means I'm going to use cosine. So here we go. Let's crank out the cosine. So cosine of angle A is going to equal to, see how much room I have here. It's going to be pretty tight. Let's just plug in. We know cosine is adjacent over hypotenuse. Adjacent is the side we want to know. Hypotenuse of the medium triangle is AC, which is 15. There we go. This has the variable on top. That means we're going to actually multiply both sides by 15, and we end up with x is equal to 15 times. I'm not going to give you much explanation for this. You should already know this. And this is cosine of angle A. And cosine of angle A is 28.072 degrees. You should know this part already. Let's put this in our calculator. Let's change the color so you see the answer. X, or our length of the side, is approximately, let's put this in our calculator and see what we get. So I've got 15 times cosine of 28.072, close parentheses, 13.235, that means it's 13.24. So, man, I keep doing that. Sorry about that. So, it's approximately 13.24, and our unit of measure is centimeters. So, there we go. We could use trigonometry to find that one. Let's do one more. How about the length of CD? Oh, CD is the altitude. And you know what? Let's use the same triangle. Let's use the medium triangle. Take a look at this. Our hypotenuse is still AC, but now instead of finding adjacent, we're going to find opposite. So if we're going to use opposite and we know the hypotenuse for the medium triangle, we're going to use sine. So sine of angle A, and I could use angle B as well if I want. Actually, I can't. I can only use angle A right now because I'm using the medium triangle. Is equal to, and we've got, let's see, opposite is CD, that's our unknown, and adjacent is, hypotenuse is 15. There you go. So there we go. Let's rewrite this. We multiply both sides by 15 because the variable is on top. 15 times sine of angle A, which is 28.072. Let's plug that into our calculator. X is approximately, let's see if I can just edit this rather than type it all from scratch. Nope, I got a backspace on this. Oops. Let's backspace and change this to sine. 15 times sine of 28.07. Oops. That mixed up. Let's try sine. Oh, goodness gracious, I'm going to keep mixing this up. Okay, 15. I'm going to use my typewriter now because I'm using my mouse. It's making it too hard for me. 15 times the sine of 28.072. And there we go. I've got 7.058. I can round that to 7.06. 7.06. Approximately 7.06. Unit of measure is still centimeters. Now, we just found two angles with this special property of right triangle similarity with an altitude. I could find every other side the same way. I could find DB. This piece right here is missing. I can find angle ACD. I can find angle DCB. Every part of this triangle, this diagram, I can solve using trigonometry because I know that these three triangles that were made are all similar. So there we go. I know that's a tough one for you, but hope you can see trigonometry comes to the rescue on what is a very difficult problem. Now certainly you could also use the properties of similarity, but I will tell you the notes are twice as long when you do that. With trigonometry, it's a whole lot easier. So hopefully you were able to follow along and that makes sense to you.